To try and show expansion and contraction in solids, I have here a top from a bulldog clip and some tongs. The tongs will just fit in. Okay, I'm going to do it better in a moment. Tongs will just fit. Okay, as you can see. Now if I heat it up, one of the problems with not being in a lab and going to be in practicals. Nice I tried to do. You see, it's not going to do it. I did this other job. If I cool it, like in the ice water we're using now, it will now go back in. So we contract it. Try it again. Leave it very hot. Okay. Easiest way of showing liquids expanding and contraction is a thermometer. I have a thermometer here. If I put it into the hot water, you can see the red indicator, which is alcohol, is rising. What's happening is the particles, the liquid particles, that's alcohol, are moving faster and faster, getting further apart from each other, taking up more space, expansion. Same idea for contraction. If I put the thermometer in there, as you can see, the temperature drops. The temperature has been measured by the red alcohol, and as the particles, the energy from in the particles that gets removed, they take up less space, so therefore we finish up with contraction. Okay. Looking at expansion and contraction of gases, I have here a small bag. It's got a small amount of air in. I dropped it in just yet. Right, you can see it's sealed. If I put it into some hot water, and this is water from a kettle, so it's reasonably warm, you can see straight away we have here what looks like a fuller bag. The air inside, the particles are moving, and they are therefore taking up more space. That is expansion. There you go. We replace the hot water with some cold water. This is some ice in water. We've still got the same bag. It's been out of the hot water for a couple of minutes, so put it back. I can put it back into the water in a minute if you want to try, but out there, if I put it into the cold water, what we should see is that the bag will contract. The air particles are getting closer together, they have less energy, and therefore take up less space. You can see there, it's not as thick, not the bag itself is not as thick. Okay, I'll leave it in long enough. We may even get it so that the air particles are that close together you don't even notice it's a sealed bag of air. There. Okay. So what is actually happening when we've got expansion? Well, remember the model, the idea of particles. These particles, especially in a solid, are all nice and regimented, but they're still vibrating slightly. So what we have is that they vibrate more, therefore taking up more space, therefore getting larger and longer. We have here 5 particles, and they're all vibrating just a little bit. You can see the room that they take up is going to be that much. Yeah. As we increase their vibration, we can see they're now taking up somewhat more room, from there to there. And as we continue on, we make it even hotter. It's got very hot now, it's red hot. Apologise for the smaller particles, they don't get any smaller. But now, that's the size of the piece of metal. In liquids and gases, it's more about the particle movement. So the particles are moving more as they take up more room. In a liquid, the particles are getting further away from each other, so they're taking up more space. In a gas, same idea. The particles are moving a lot faster, they're moving a lot further away from each other, so again, they take up more space. And the reverse is true for contraction. As you take away the amount of energy that's there, you reduce the size of it. So, as we take away a lot of energy from a gas, we turn it back into a liquid. And if we keep taking that energy away, we turn it into a solid.